Those worlds in space are as countless as all the grains of sand on all the beaches of the Earth. Each of those worlds is as real as ours. In every one of them, there's a succession of incidents, events, occurrences, which influence its future. Countless worlds, numberless moments, an immensity of space and time. And our small planet, at this moment, here we face a critical branch point in history. What we do with our world right now will propagate down through the centuries and powerfully affect the destiny of our descendants. It is well within our power to destroy our civilization and perhaps our species as well. If we capitulate to superstition or greed or stupidity, we can plunge our world into a darkness deeper than the time between the collapse of classical civilization and the Italian Renaissance. But we are also capable of using our compassion and our intelligence, our technology and our wealth to make an abundant and meaningful life for every inhabitant of this planet, to enhance enormously our understanding of the universe and to carry us to the stars.
In recent years, we've learned much more about the origin of life. Do you remember RNA, that nucleic acid that our cells use as messengers carrying the genetic information out of the cell nucleus? Well, it's been found that RNA, like protein, can control chemical reactions, as well as reproduce itself, which proteins can't do. Many scientists are now wondering if the first life on Earth was an RNA molecule. And it now seems feasible that key molecular building blocks for the origin of life fell out of the skies 4 billion years ago. Comets have now been found to have a lot of organic molecules in them, and they fell in huge numbers on the primitive Earth. We also mentioned the extinction of the dinosaurs and most of the other species of life on Earth about 65 million years ago. We now know that a large comet hit the Earth at just that time. The dust pall from that collision must have cooled and darkened the Earth, perhaps killing all the dinosaurs, but sparing the small, furry mammals who were our ancestors. Other cometary mass extinctions in other epochs seem likely. If true, this would mean that comets have been the bringers both of life and death. In the history of the solar system, have worlds ever been destroyed? Most of the moons in the outer solar system have craters on them made by cometary impacts. Some have such large craters, though, that if the impacting comets had been just a little bit bigger, the moons would have been shattered. What would the results of such a collision look like? Maybe a planetary ring. The idea has been growing that little worlds are every now and then demolished by a cometary impact. The fragments then slowly coalesce and a moon arises again from its own ashes. Some moons may have been destroyed and reconstituted many times. For our own world, the peril is more subtle. Since this series was first broadcast, the dangers of the increasing greenhouse effect have become much more clear. We burn fossil fuels like coal and gas and petroleum, putting more carbon dioxide into the atmosphere and thereby heating the Earth. The hellish conditions on Venus are a reminder that this is serious business. Computer models that successfully explain the climates of other planets predict the deaths of forests, parched croplands, the flooding of coastal cities, environmental refugees, widespread disasters in the next century, unless we change our ways. What do we have to do? 4 things. 1, much more efficient use of fossil fuels. Why not cars that get 70 miles a gallon instead of 25? 2, research and development on safe alternative energy sources, especially solar power. 3, reforestation on a grand scale. And 4, helping to bring the billion poorest people on the planet to self-sufficiency, which is the key step in curbing world population growth. Every one of these steps makes sense apart from greenhouse warming. Now, no one has proposed that the trouble with Venus is that there once was Venusians who drove fuel-inefficient cars, but our nearest neighbor, nevertheless, is a stark warning on the possible fate of an Earth-like world. Mars today is strictly relevant to the global environment of the Earth. Its antiseptic surface is a cautionary tale of what happens if you don't have an ozone layer. Its great dust storms and the resulting cooling of its surface played a role in the discovery of nuclear winter, the catastrophic climate change on Earth predicted to follow nuclear war. So if you didn't have an ounce of adventuresome spirit in you, it would still make sense to support the exploration of Mars. In recent years, there's been a groundswell of interest in organizing the first expedition of humans to go to the planet Mars. We first need more robotic missions, including rovers, balloons, and return sample missions, and more experience in long-duration spaceflight. But eventually, if all goes well, the interplanetary ship or ships would be constructed in Earth orbit, launched on the long journey to Mars, and then a landing module would sit down on the surface. The crew would emerge, making the first human footfalls on another planet. It would be very expensive, of course, although cheaper if many nations share the cost. The key issue in my mind is whether the unmet needs down here on Earth should take priority. But that's a question even more appropriately addressed to the military budgets. Now, $1 trillion a year worldwide. You can buy a lot for that. Justifications for the Mars endeavor have been offered in terms of scientific exploration, developing technology, international cooperation, education, the environment. Some see it as the obvious response to the future calling. Some even think we should go to investigate enigmatic landforms, including one that resembles an enormous human face. Personally, I think this, like hundreds of other blocky mesas there, is sculpted by the high-speed winds. But if we're going anyway, there's no harm in taking a look. A remarkably diverse group of American leaders has endorsed the Mars goal. I imagine the emissaries from Earth, citizens of many nations, wandering down an ancient river valley on Mars, trying to understand how a quite Earth-like world was converted into a permanent ice age, and looking for signs of ancient life along the river banks. In the long run, the significance of such a mission is nothing less than the conversion of humanity into a multi-planet species. Since Cosmos was first shown, Voyager spacecraft have explored the systems of the planets Saturn, Uranus, and Neptune, and have now passed the outermost planets on their way to the stars. We inserted a flavor of those encounters in our captain's log, but with image processing, we've been able to reconstruct astonishing movies of some of these worlds. Here, for example, is Jupiter with its great red spot, and volcanic Io spinning before us. Icy Enceladus, a tiny moon of Saturn on much of which, somehow, the craters have melted. And Miranda of Uranus. Austere blue Neptune. Or consider Titan, the giant moon of Saturn. We've taken the nitrogen and methane in its atmosphere, irradiated it in the lab with electrons of the sort that are beamed at Titan from Saturn's magnetic field, and we make this stuff, which matches almost perfectly the observed properties of the Titan haze. What is it? It's a mixture of complex organic molecules. You drop some of the stuff into water, and among other things, you make amino acids, the building blocks of proteins. So the starting materials of life are raining from the skies of Titan, like manna from heaven. I can't wait until the Cassini mission sends an entry probe through the organic haze of Titan to its enigmatic surface. The Voyager spacecraft rush on past the planets and to the stars, still returning data. As it left the planetary part of the solar system, Voyager 1 turned back to take one last portrait of the planets of the solar system. And one of those pictures was of the Earth, a tiny blue dot set in a sunbeam. Here it is. That's where we live. That's home. We humans are one species, and this is our world. It is our responsibility to cherish it. Of all the worlds in our solar system, the only one, so far as we know, graced by life. In our motorbike sequence, we showed how the landscape might look if we were barreling through it at close to the speed of light. Since then, inspired by this sequence, Ping Kang Seung at Carnegie Mellon University produced an exact computer animation. This is what you'd see if you were traveling at ordinary speeds through this red and white lattice. But this is how it would appear if you were traveling the same route at close to the speed of light. We're probably many centuries away from traveling close to the speed of light and experiencing time dilation. But even then, it might not be fast enough if we wanted to travel to some distant place in the galaxy, say, and then come back to Earth in our own epoch. Some years after completing Cosmos, I found myself taking time out from my scientific work to write a novel about travel to the center of the Milky Way galaxy. I was willing to imagine beings and civilizations far more advanced than we, but I wasn't willing to ignore the laws of physics. Was there, even in principle, a way to get very quickly to 30,000 light years from Earth? So I put this question to my friend Kip Thorne of the California Institute of Technology. He's a leading expert on the nature of space and time. Kip thought about it for a while and then answered with about 50 lines of equations, which showed that a really advanced civilization might establish and hold open wormholes, which we might think of as tubes through the fourth dimension, which connect the Earth with another place in the universe without having to traverse the intervening distance, something like crawling through a wormhole in an apple. I was very happy with this result, and I used it as a key plot device in Contact. But such wormholes through space would also be time machines, it seemed to me. And I used that notion in my novel Contact as well. Kip Thorne and his colleagues later proved, or so it seemed, that time travel of this sort was possible. Here, look at this. The key question being explored now is whether such time travel can be done consistently, with causes preceding effects, say, rather than following them. Does nature contrive it so that even with a time machine, you can intervene to prevent your own conception, for example? Even if time travel of this sort is really possible, it's far in our technological future. But maybe other beings, much more advanced than we, are voyaging to the far future and the remote past, not a measly 40 years ago on Earth, but to witness the death of the sun, say, or the origin of the cosmos. I only have a moment, but I wanted you to see a picture of Betelgeuse, that's what it's called, in the constellation Orion, the first image of the surface of another star. But the most exciting recent stellar discovery has been of a nearby supernova in a companion galaxy to the Milky Way. We are here witnessing chemical elements in the process of synthesis and have had our first glimpse of the supernova through a brand new field, neutrino astronomy. And we're now seeing around neighboring stars disks of gas and dust just like those needed to explain the origin of the planets in our solar system. Worlds may be forming here. It's like a snapshot of our solar system's past. And there are so many such disks being found these days that planets may be very common among the stars of the Milky Way. Except for planetary exploration, the study of galaxies and cosmology, what this episode was about, have undergone the greatest advances since Cosmos was first broadcast. For one thing, at last we have a good photograph of our own Milky Way galaxy, about 100,000 light years across. Here it is. It was taken by NASA's COBE satellite. We see it edge on, of course, since we're embedded in the plane of the galaxy. But you don't need a spacecraft to see it. If it's a clear night tonight, why not go out and take a look at the Milky Way? There's also new evidence suggesting that the Milky Way is not so much an ordinary spiral galaxy as a barred spiral, like this. Important work has now been done on mapping how the galaxies are scattered through intergalactic space. To the surprise of a lot of scientists, on a scale of hundreds of millions of light years, the galaxies turn out not to be strewn at random or concentrated in clusters of galaxies, but instead strung out along odd, irregular surfaces, like this. Every dot in this computer animation is a galaxy. The computer lets us look at this distribution of galaxies from many points of view, but this is how it looks from the Earth. There's an odd mannequin shape that is presented by the distribution of galaxies. This work has been done mainly by Margaret Geller with her collaborator John Huckra at Harvard University and the Smithsonian Institution. It's a little like soap bubbles in a bathtub or in dishwashing detergent. The galaxies are on the surfaces of the bubbles. The insides of the bubbles seem to have almost no galaxies in them at all. An average bubble is about 100 million light years across. And that means that we've mapped still only a very small volume of the accessible universe, the galaxies nearest to us. But pretty soon, we should be able to extend this search out to enormous distances, out to distances so far away in space that we're looking back to the time that galaxies and their structures were first forming. And this poses a real problem. Most cosmologists hold that the galaxies arise from a pre-existing lumpiness in the early universe, with little lumps growing into galaxies. But the background radiation from the Big Bang that fills all of space has now been carefully measured by that same COBE satellite that took that picture. Now, those radio waves seem almost perfectly uniform across the sky, as if the Big Bang weren't lumpy or granular at all. But if the early radiation and matter in the universe weren't lumpy, how could individual galaxies form? How could the bubbles form? Is there a contradiction between the uniformity of the Big Bang radio waves and the bubble structures formed by the galaxies? That's the question. When our survey of the galaxies reaches out to billions of light years, we'll have the answer to this question. Incidentally, maybe you're thinking that the bubbles imply a bubble maker. But then I'd have to ask you, who made the bubble maker? There's another infinite regress lurking here. And to one of the grandest questions, whether there's enough matter in the universe to close it, the only fair answer is that we still don't know. If it is closed, what is the hidden matter that's closing it? Is it faint stars, black holes, massive neutrinos, some exotic kind of dark matter unknown on Earth? We don't know. But there are reasons to think that we'll soon find out the answers. Since Cosmos was first released, interest in UFOs has persisted. It seems to me that there are fewer sightings of strange objects in the skies these days, and more stories about personal encounters with alleged extraterrestrials, like the account of Betty and Barney Hill that we dramatized. There are still people who claim to have been abducted by aliens, or even sexually abused, or even impregnated by them. Best-selling, purportedly serious books have been written about such claims. But the critical fact remains that all we have still is just anecdote. There are no close-up photographs, no artifacts, nothing that would convince a skeptic. All there are is stories. And stories just aren't good enough on a matter of this importance. I'm still waiting for hard evidence. The radio's search for extraterrestrial intelligence has been picking up. In Harvard, Massachusetts, a radio telescope monitoring 8 million separate radio channels has been scanning the skies for signals. This program, called META, is supported entirely by the Pasadena, California-based Planetary Society, paid for by members' contributions. A similar Planetary Society search to examine the southern skies, including the center of the Milky Way galaxy, is to be performed in Argentina. These searches are, by far, the most sophisticated ever attempted. A much more sensitive program, covering almost the entire accessible radio spectrum, is to be mustered by NASA. The search for extraterrestrial intelligence is central to our understanding of the universe and our view of ourselves. It's well worth doing. But the simple fact is that while we may consider extraterrestrial intelligence highly likely, there is as yet no evidence at all that it exists. The search continues. The greatest thrill for me in reliving this adventure has been not just that we've completed the preliminary reconnaissance with spacecraft of the entire solar system, and not just that we've discovered astonishing structures in the realm of the galaxies, but especially that some of Cosmos's boldest dreams about this world are coming closer to reality. Since this series' maiden voyage, the impossible has come to pass. Mighty walls that maintained insuperable ideological differences have come tumbling down. Deadly enemies have embraced and begun to work together. The imperative to cherish the Earth and to protect the global environment that sustains all of us has become widely accepted. And we've begun, finally, the process of reducing the obscene number of weapons of mass destruction. Perhaps we have, after all, decided to choose life. But we still have light years to go to ensure that choice. Even after the summits and the ceremonies and the treaties, there are still some 50,000 nuclear weapons in the world. And it would require the detonation of only a tiny fraction of them to produce a nuclear winter, the predicted global climatic catastrophe that would result from the smoke and the dust lifted into the atmosphere by burning cities and petroleum facilities. The world scientific community has begun to sound the alarm about the grave dangers posed by depleting the protective ozone shield and by greenhouse warming. And again, we're taking some mitigating steps. But again, those steps are too small and too slow. The discovery that such a thing as nuclear winter was really possible evolved out of studies of Martian dust storms. The surface of Mars, fried by ultraviolet light, is also a reminder of why it's important to keep our ozone layer intact. The runaway greenhouse effect on Venus is a valuable reminder that we must take the increasing greenhouse effect on Earth seriously. Important lessons about our environment have come from spacecraft missions to the planets. By exploring other worlds, we safeguard this one. By itself, I think this fact more than justifies the money our species has spent in sending ships to other worlds. It is our fate to live during one of the most perilous, and at the same time one of the most hopeful chapters in human history. Our science and our technology have posed us a profound question. Will we learn to use these tools with wisdom and foresight before it's too late? Will we see our species safely through this difficult passage so that our children and grandchildren will continue the great journey of discovery still deeper into the mysteries of the cosmos. That same rocket and nuclear and computer technology that sends our ships past the farthest known planet can also be used to destroy our global civilization. Exactly the same technology can be used for good and for evil. It is as if there were a God who said to us, I set before you two ways. You can use your technology to destroy yourselves or to carry you to the planets and the stars. It's up to you.